Paris is very old. There has been a settlement there for at least 6,000 years, and its shape has been determined in part by the river Seine, and in part by the edicts of France's rulers. But the great boulevards we admire today are relatively new, and were constructed to prevent any more barricades from being created by the rebellious population. That work was carried out in the middle 19th century. The earlier Paris had been in part a maze of narrow streets and alleyways. But you can imagine that the work was not only highly expensive, but caused great distress among the 500,000 or so residents whose houses were simply razed, and whose neighborhoods disappeared. What is done cannot usually be undone, especially when buildings are torn down.
Look at any photo of Earth's night side, and you see the planet lit up like a Christmas decoration. As the glowing lights of bustling cities expand, the serenity of natural darkness wanes. But the repercussions are not just the loss of the starry night sky. Light pollution also affects animals who depend on a nighttime environment to survive. Many bird species use the stars to navigate at night. Baby sea turtles use moonlight reflected off the ocean to guide them back to the water. City lights can confuse them and veer them off course. Humans are not immune either. Excessive exposure to artificial light at night can increase the risk of sleep disorders, and it's also been linked to obesity, depression, diabetes, and even cancer.
So the pace at which human minds have evolved over the last million years, and more recently probably the last 200,000 years, has been so frighteningly rapid that, I mean, the evolution of cognitive function and perception can only occur in small number of genes. If one needed to adapt dozens of gene changes in concert in order to acquire the penetrating minds that we now have, which our ancestors 5,000 years ago didn't have, the evolution could not have taken place. It really couldn't have occurred so quickly. And so for that reason alone, one begins to really suspect that, the genetic differences between people who say lived 5,000 years ago is evidence that the difference between their cognitive functions and ours is not actually as large. Therefore, I mean, a rather small number of genes may be responsible for the powerful minds that humans have, which most of us now possess.
Indeed, the library. We've all been to a historic library. We've all enjoyed the smell of a historic library, but what is it and what does it mean? When the UCLA Center for Sustainable Heritage, we've recently been asked to assess the environment at another historic library at St. Paul's Cathedral, the Wren Library, an incredible place. And it has such an intensive smell of old books. And we were also asked for the first time read. I was actually quite taken aback by the brief. We were asked, whatever you do, please preserve the smell. It's so important to our audience. It's so important how people perceive the library. So that was quite an important message in our research. And indeed, the smell is an important way of how we communicate with the environment. This piece of research was done by an advertising company because advertisers are so interested in how we interact with each other and the environment, and we see that the majority of people use sight, obviously, to interact with the environment. But on the second place, we see that smell is also very, very important. It is also very, very interesting.
This is Hans Krebs, who in 1937 published a paper showing the sequence of chemical reactions, by which energy is released in individual cells. It's called the Krebs cycle, which some of you may remember from your chemistry course in high school. Krebs is a wonderful example to me of how a scientist who is determined can overcome all kinds of human obstacles. Krebs' father constantly discouraged him and told him that he had just mediocre intelligence and would never do anything important in his life as a teenager. What Krebs remembers in his memoir, his father said to him, "You can't make a silk purse out of a sow's ear." And later on, when Krebs studied with the great biochemist Otto Warburg, Warburg also told him the same thing, not the same quotes, but that he had only mediocre ability and would never be a great scientist. And we all hear about how important it is for parents to encourage their children, but sometimes the children will go on to do great things no matter what we say to them.
A leader can define or clarify goals by issuing a memo or an executive order, an edict or a fatwa or a tweet, bypassing a law, barking a command, or presenting an interesting idea in a meeting of colleagues. Leaders can mobilize people's energies in ways that range from subtle, quiet persuasion to the coercive threat or the use of deadly force. Sometimes a charismatic leader, such as Martin Luther King Jr., can define goals and mobilize energies through rhetoric and the power of example. We can think of leadership as a spectrum, in terms of both visibility and the power the leader wields. On one end of the spectrum, we have the most visible, authoritative leaders like the President of the United States or the Prime Minister of the United Kingdom, or a dictator such as Hitler or Gaddafi. At the opposite end of the spectrum is casual, low-key leadership found in countless situations every day around the world. Leadership that can make a significant difference to the individuals whose lives are touched by it. Over the centuries, the first kind, the out-in-front, authoritative leadership, has generally been exhibited by men. Some men in positions of great authority, including Nelson Mandela, have chosen a strategy of leading from behind. More often, however, top leaders have been quite visible in their exercise of power. Women, as well as some men, have provided casual, low-key leadership behind the scenes. But this pattern has been changing, as more women have taken up opportunities for visible, authoritative leadership.
Discovered around the end of the 19th century, the noble gases are the most stable group of the chemical elements. The six gases, helium, neon, argon, krypton, xenon, and radon, have a myriad of modern uses. When they were first discovered, their strangely standoffish properties were a mystery. Uniquely stable, they seem to participate in no chemical reactions. But by understanding the stability of the noble gases, physicists discovered the key to chemical bonding itself. Dmitry Mendeleev added the noble gases to his periodic table in 1902, where he arranged the elements in rows and columns according to their atomic weight. Mendeleev was able to see repeating, or periodic, patterns in their properties. The noble gases appeared regularly in the periodic table, occurring in every eighth position, at least amongst the lighter elements. Physicists struggled to find a model that would explain this curious observation. What was the significance of the number 8?
To be a successful entrepreneur, you should have good ideas. But the definition of a good idea varies depending on whom you ask. A great idea should have several features. Firstly, the great idea should be various and novel. Secondly, the great idea should be unique, which means no one has thought about it. Thirdly, it is essential for great ideas to be transformative and productive. All ideas are essentially a combination of other smaller ideas. But this doesn't mean they can't be unique. Merely copying doesn't make anything idiosyncratic. It's the individuality that one puts in which makes a concept stand out. Constant innovation leaves no room for stagnation and thus adds on to the basic idea, effectively making it unique. Unique ideas are inspired by basic things. They are simply extensions of pre-existing notions. And an idea or a concept is unique only when it transcends its predecessor and serves its purpose in a better and more precise way.
Well, what I want to focus on now is climate change, more specifically on the fact that climate change is a result of human activities. Now, there has been some disagreement regarding the extent to which human activity can be blamed for climate change. But I want to argue that there is evidence which clearly demonstrates that our own actions really are causing a genuine threat. The available evidence seems to indicate fairly conclusively that land and sea temperatures started to increase around 200 years ago. So, what's the significance of this? Well, 200 years ago roughly coincides with the beginning of the Industrial Revolution in the Northern Hemisphere. In other words, this was when our production of harmful gases really got going as a result of increased industrialization. Since that time, our production of gases has accelerated due to the fact that not only has industry grown in size, but it has also now spread to the southern hemisphere, indeed most parts of the world. So, in the last 200 years, as industry has grown, we can see a gradual rise in the temperatures, which, to my mind, is sufficient proof of the damaging effect of our actions, and needless to say, it's an issue which we need to address.
The history of software is, of course, very, very new. The whole IT industry is really only 67 years old, which is extraordinary. To be so close to the birth of a major new technology, a major new discipline, is quite remarkable given where we've got to in those 67 years. And the progression has been not so much a progression as a stampede, because Moore's law, the rapid expansion in the power of computing and the rapid fall of the cost of computing and storage and communications, has made it feasible for information technology to move into all sorts of areas of life that were never originally envisaged. What has happened is that there has been, as I said, a stampede for people to pick the low-hanging fruit. And that is what's guided the development of software and information technology over the past decades, and continues to do so, with a number of consequences that we will explore.
Nikola Tesla, living under the shadow of Thomas Edison. Tesla is less alone, but his theories have given him a special place in the field. Here we try to showcase some interesting facts that have come to light about Tesla. He was an electric engineer and a physicist of repute. He had over 300 patents credited to him, but he became famous for developing the alternate current technology, which has a wide variety of uses. He was known for his hysteric sense of humor. The museum in Wardenclyffe was funded by a cartoon showing the respect people had for his humor. Tesla, in the initial years, worked for Thomas Edison designing direct current generators. He moved away to pursue his own research. Though people described them as rivals, the fact of the matter is that they were two sides of a coin. Tesla was at heart an environmentalist and was concerned about the way people were using the resources. He looked for ways to make renewable resources. In fact, he created artificial lightning in his lab and found differences in electric potential on Earth and high objects. As early as 1901, he had ideas about smartphone technology. He was a brilliant thinker but could not put his thoughts and ideas into practice. Tesla never bothered about monetary gains for his research and many a time did not have funds to work on his ideas. People term him a brilliant thinker and humanist. It is said that he had an earthquake mission in his lab and on many occasions he would frighten the entire neighborhood when he used it. It is said that Mark Twain was one of the victims of this exercise.
In today's class, we'll be examining some 19th century pattern books that were used for building houses. I think it's fair to say that these pattern books were the most important influence on the design of North American houses during the 19th century. This was because most people who wanted to build a house couldn't afford to hire an architect. Instead, they bought a pattern book, picked out a plan, and took it to the builder. The difference in cost was substantial. In 1870, for example, hiring an architect would have cost about $100. At the same time, a pattern book written by an architect costs only $5. At that price, it's easy to see why pattern books were so popular. Some are back in print again today, and of course, they cost a lot more than they did 100 years ago. But they're an invaluable resource for historians, and also for people who restore old houses. I have a modern reprint here that I'll be passing around the room in a moment so that everyone can have a look.
This is Scientific American's 60-Second Science. I'm Steve Mirsky. Got a minute? Why do bumblebees pick some flowers over others? Researchers have known for a while that a flower's color can be a signal. Color is shorthand that says to a bee, hey, I got some good quality nectar here. Why don't you stop by for a visit? But new findings show that bees also use color to get clues about a flower's temperature. And according to a study from a British research team published in the journal Nature, some like it hot. Bees use up a lot of energy just staying warm on some days. In fact, they can't even fly if they're too cold. So if one flower is warmer than another, a bee can save some of its fuel by basking on that flower while it's doing its pollinating business. And it turns out that bumblebees consistently do choose warmer flowers over cooler ones, even when the two flowers offered up the same quantity and quality of nectar. Some plants seem to be evolutionarily adapted to be slightly warmer because the warmer ones get visited more by the chilly bees. When it comes to getting pollinated, apparently the heat is on, and that's the buzz.
Are you a chocolate lover? Even true chocoholics might not know what their favorite treat has in common with yogurt, cheese, and wine. Its flavors come from fermentation. Fermentation is the process of improving a food through the controlled activity of microbes. The food you know as chocolate starts its life as the seeds of football-shaped fruit. Farmers scoop out the seeds and pulp into piles or boxes. The seeds are now called cacao beans. They ferment for about a week before they're dried, roasted, and crushed with sugar until smooth and ready to eat. Let's go back to that fermentation step. Cacao fermentation is a multi-stage process. The first stage involves yeast. Just like the yeast in your beer, yeast in a cacao fermentation produces alcohol by digesting the sugary pulp around the beans. As the pulp breaks down, oxygen seeps in, and oxygen-loving bacteria take over. the bacteria generate acetic acid from the alcohol that the yeast produced. Acetic acid causes biochemical changes as it soaks into the beans, and that has a major impact on flavor. Finally, as the acid slowly evaporates and the sugars are all used up, spore-forming organisms begin to grow. Cacao is a wild fermentation. Farmers rely on natural microbes in their environment to create unique, local flavors.
Over the last decade, the share of the world's population living under autocracy increased from 48 to 68%. It is more important than ever to understand how autocracies work. Autocrats have a keen interest in promoting the idea that they are all-powerful. Whereas leaders in democracies can be removed via elections, leaders in autocracies can lose office in two ways: via coup or popular revolt. To make matters worse, autocrats can rarely address both threats at the same time. They often have to choose whether to reward their elite cronies to prevent a coup or the masses to prevent a revolt. This generates many difficult trade-offs. Cheat too little on elections and risk losing office, but cheat too much and signal weakness to your opponents. Use corruption to reward your elite friends, but not so much that it slows economic growth and sparks a revolt. Manipulate the media, but not so much that people turn off the television. Repress your political opponents, but not so much that it causes a backlash. Empower the security services, but not so much that they can overthrow you. Rulers who fail to resolve these trade-offs often suffer the consequences.